All right, so if you suffered through those first two videos, which was all computer work, and quite frankly, it probably wasn't very entertaining. I'm sorry. It's hard to make computer work entertaining, but there are some good tips in there. At this point in time, we're ready to actually bring it to the laser and do something with it. Now I'm going to put timestamps into here because I'm going to break this video up into two parts. The first part is going to be, what if you don't have a laser and you're interested in getting a laser, and what does it involve to actually get a laser or to move forward with it? And then the second part will be setting up, and we'll do some cuts and kind of show you what's involved with that. And it's all relatively easy. But the most complicated part is, of course, if you've never dealt with lasers, is, of course, buying one that meets your needs. I'm going to make an assumption that, mainly because maybe not everybody knows, and it'll be easier if we're on the same sheet of music. So I'm going to assume you know nothing about the lasers, and so we'll move forward from there. What you're going to find as you're going out there looking for lasers is you're going to find lasers that are milliwatts and lasers that are watts. Milliwatt lasers are usually used for just engraving. Engraving leather or things of those nature. They can cut through very thin, light product like paper and things like that, cardstock and cardboard. But they're not really designed for what we want to do for cutting models. If you're looking for a laser, you need to understand that 40 watts needs to be the lowest wattage that you're looking for. And even that is going to be tough if you want to cut 1/8" MDF. The products I use mostly are MDF, polybak, basswood, real thin plywood you can get in 32nd and 64th. So those type of products. I also cut acrylic. Those type of products, you know, you're going to want to be probably no lower than 40 watts. I would really recommend that you get a 50 or 60 watts. I have a 60 watt laser on this one here. And most of my cuts range from about 44 watts to, when I'm cutting the MDF, I'm probably getting close to 50, 55 watts of power coming out of the laser. So that gives you an idea of what you're looking at. So when you're looking for that type of, laser, what do I get? That's one of the things you take a look at. The other thing that you're going to look at is size. And size may or may not matter to you. If you're an N-scale modeler, one of the Chinese 12x8s, and we'll get into that in just a minute, that 12x8 bed is probably more than adequate for you to build most of your models in N-scale. If you're doing HO scale, and you want to get to something bigger than the 8x12 bed, then you're going to have to look for a bigger laser. If you're doing O scale, I guarantee you're going to want a bigger laser than one of those Chinese lasers. But again, maybe you're not making models that size. And again, that's why it's very personal. What is it that you want to do? The other thing that's going to come into play is there's a bed, a Z-bed axis. The Chinese laser ones that come out, their beds don't move. My bed does not move. I actually bought a movable, moving up and down the Z-axis bed for my Chinese laser, thinking that I was going to use it. What I found more than anything else is it sat in the one position where I cut 90% of my product. And I just did not do that on this laser because it made no sense. I'm just not using the laser much different than between paper thin or 17 thousandths to 1/8 of an inch. And then in addition to it, if I want to do standoff so I'm not getting reflectivity off of my aluminum honeycomb bed, on my product. I'm only lifting it up 6 millimeters, so it's 6 millimeters plus what I already had in there. So the laser head on this, what I did is it made the laser head adjustable so that I could meet that need. And then I didn't have to make it, and it's manually adjustable. It's not done with motors. That made it easier to build. So that's, you know, something you might want to take a look at. If you're going to be engraving wine bottles or champagne glasses or whatever, that, you know, there's other things that people do. You can look online, you see lots of people do it. You're going to need to be able to move that Z bed. Beyond that, I would break this down into two different categories for the lasers. There's the cheap Chinese made ones and the more expensive ones. Now there are a couple in between there. I'm not going to deny that. I can think of a couple companies right off the bat that make some lasers that fall in between the high quality US ones and the cheap Chinese ones. And some of them are US based companies. I'm not discouraged. I'm not saying they're bad or anything. One in particular I can think of off of the top of my head has had terrible customer service, and I've actually had a conversation with a couple individuals that had to deal with them, and they are just they've had much difficulty working with them. So my suggestion, if you're looking at buying a laser, that you certainly research, because if you do not have the technical knowledge to do it yourself, they are going to be your lifeline. If you build your own, there are plenty of places out there. I really would recommend type into Google OpenBuild. You'll find that there's an OpenBuild store and there's an OpenBuild blog site in which lots of plans for this type of stuff. And don't be limited just because it says it's a laser engraver or cutter. The CNC machines that they also have plans for are really fantastic, and a lot of the CNC stuff that I took from some of the CNC plans I implemented into my laser. CNC machines have to be much more robust because you got a spindle that's spinning, where a laser head, there's no torque, none of those type of things. But that doesn't mean you can't use some of the ideas from both of them. And I found it to be very handy. So that being said, let's look at what's the difference between building your own and buying one. The biggest difference is going to be, if you build it, you are tech support. You are the person that's going to have to repair it and fix it. I have a lifetime warranty on this instrument. As long as I'm alive, I will be repairing this instrument. That's the warranty. And it works. It works for me because I'm familiar with many of the electronics and the mechanics that are in here. And, you know, even just the other day, I saw something that, you know, and I designed it, and I sat back and went, you know, if I did this, this would be easier. And so I made that modification to the mirrors. And it is. It's easier. It works fantastic. So that being said, that's some of what I do with this. If you are not technically apt to have that aptitude to, or want to, I mean, let's be fair about it. Some people just don't want to either, and don't want to service and repair something like this, then the next option is, of course, to buy one from somebody. And I would, again, I'm not recommending any companies. I'm not going to say anything bad about any companies, but there are two companies I will, you know, Boss Lasers and Epilogue. Both of them are very reputable companies. I've listened to or read many of the blogs from people that have been working with them. They're very supportive of these two companies. The price range to get a laser about this size, they sell, Boss sells a 16 by 14 inch. That's about $4,000. If you go to the next step, you're getting like $6,000 or $7,000, which is about the size that I have here, which is this one in particular is 24 inches by 33 and a half. So it'd be 24 by 36 would be probably the next size that they would have that's comparable to this one. I think it's about, and again, I have a 60-watt laser, and I think the one I saw was 50 watts, was about 7. Don't quote me exactly, but you know, again, around that price range. Some of the other advantages to buying a US-based one is the computer software is much, much more robust. The system I have here is one of the cheap Chinese knockoffs. There are some good ones out there. There are some that run a company, the software they run is RDWorks. The RDWorks software is still not as robust as I think as some of the US-based ones, but it is certainly better than the one I have here. But they're very similar in how they function. So that being said, the controller for my system here ran me about $400. RDWorks runs about $500. Some of these you can find some other ones that are out there. I know there are some people that are doing Arduino-based type controllers and everything. I did not want to get into that programming, so I just bought one of these just to make my life easy, and it works fine. I don't have any problems with it. It works. I got maybe a couple extra steps that I have to manually do, but yeah, that's fine. It's not a big deal. I also will tell you that in the Chinese ones, originally when I bought my Chinese-made one, they were 6-inch by 4-inch, 6 by 5-inch roughly, is what they were selling them out as. And of course, with some simple modifications of you know, taking out the bed, putting in a bigger bed, removing some of the stops. They had room enough to do an 8 by 12 right in there already. And if you look at eBay or even Amazon today, you'll find that they've actually done those modifications and they're selling them as 8 by 12. They range from about $325 to about $400. Now, they're basically all the same in that price range. There's very little difference between them. An emergency stop button or you know, those type of things difference between some of them. They're all about 40-watt tubes, and I will just be honest with you. Just an example, the laser I bought, it quoted that it was FDA approved. Last time I checked, the FDA is not approving lasers from China. But, you know, hey, it was a great marketing play for them. You know, it is China. But we've come past that, and they've done some improvements on their laser that were certainly possible to be done and easy to do. So, that being said, I'm not going to say don't get a Chinese laser because, you know, they work fine. You just need to decide if it's going to meet your needs. If you buy one, understand you are not going to get much technical support, if any at all. Even if you buy them and they're here in the US, you will get little tech support. Little. So it's on you to do that. Where if you're looking at Boss or Epilogue, those companies are going to stand behind their product and certainly do a better job in that area. Again, I am not endorsing Boss or Epilogue. I just know that those two companies are doing that. So that's pretty much what's involved with it. I mean, you want to look at size. Laser watt power is absolutely one of these things. Again, if you find a cheap Chinese 50-watt laser, and I'll be honest with you, the price of these lasers has come down. eBay and Amazon are both showing 50-watt Chinese lasers that are up close to this size that are ranging between $1,500 and $1,700, even reaching up to $2,000. And if you look at what people are saying about the best laser engraver cutters for 2018, some of these Chinese ones are still sitting on the top of the list because price versus what you get. Their price are just so low that it's hard not to look at them, and they do the job. So that being said, I'm not going to say don't get one of those, because frankly, if I were to do it today, this laser for me to build was $2,000, and if I was starting from scratch and didn't have parts when I started to do this project, I probably would have looked at one of those $1,500 to $1,700 ones and said, yeah, I'm going to go for it. So again, it's not saying that these Chinese lasers aren't any good. Frankly, you know, like I said, I just took mine and just put it on steroids. So that being said, that's really what's involved in getting a laser. Now, the next question is, well, okay, but why? Okay, so I have a 900 square foot building that I've got to put models into, and I wanted to do two different things. My models that I wanted to do, I wanted them to be bigger than the trains, because guess what? They are in real life. This is one of the problems I have with model manufacturers. Many of the models are so small that, you know, I'm like, yeah, that's not an industry that's going to even see a boxcar in front of it, let alone anything else. But I was going to build some models in some complexes that were large, and I was looking at 12 to 24 inches for some of my buildings. And that's why I built the laser, because A, there are no models available, and B, anybody who's done Craftsman kits knows that if you get a reputable size Craftsman kit, you're going to spend $300. Well, you put 7 or 8 of those on your table, I paid for the laser. So price on return investment here is that I'm going to be able to build Craftsman's quality kits for myself and make my money back. So for me to do like the Colorado Saddle Company, I think all said and done, the material probably is going to run me $40. That's it. That $40 to build a 12 to 15 inch by 8 inch tall, 6 inches deep building. Go ahead and find one of those for $40 today. So I can do that. It means I have to put the effort in to actually design it and figure it out. But that is not an impossible task. So that's why a laser, that's what you're looking at. So we'll then move on here, and we'll go to what's it take to download the files and to actually cut a part of the kit out. We've got some windows that I'm cutting out for the Colorado Saddle Company. So we'll zoom in here and we'll pick it up from there. Okay, welcome to the second half of the video. If you skipped the first half and you're here at the second half, welcome. If you coming from the first half, we're now going to set this up as we discussed earlier on doing the cut. I'm not really going to go through everything that you have to do, like the alignments and everything, but understand that this is an important aspect of cutting with a laser. If the laser beam is not aligned up to hit the center of the mirrors and to the center of the beam, you're going to lose power. One of the reasons why I really recommend getting a 60-watt laser, because if you lose a few watts here or there, you still have adequate power to actually cut anything that you want to cut. And there are some limitations on what the laser can cut. If you Google that, you'll find some of them. One of the primary things that I would never cut is PVC piping. PVC releases chlorine gas when you cut it with a laser. It's bad for your laser and certainly bad for you. So, you know, that's an example of something you don't want to do. I built my own laser, and if you saw on the Facebook page, I kind of gave a little snippets here and there as I was building. It took me about 6 weeks to build this laser, and I took my old Chinese laser and took many of the parts from it to to build this new one. I did upgrade the motors, I upgraded many of the controllers and things like that, but this controller here, the laser controller, is the exact same one I used on my Chinese laser, and the laser tube is the same thing for my Chinese laser, just it's got a different housing, it's got different mounts and things like that, but for the most part, those are some of the same things. All the mechanical works are in here, all were redone. If you're interested in building your own laser, I would highly recommend that you take a look at OpenBuild. It's a website, and they have a store that they sell many of these parts. But they also have, it's a group area where it's a forum that they have people that share their plans and different things on there. So there's lots of ideas in there on what to do, and you can then take a look at that and decide if you want to build your own. Products that you're going to cut on this. If you didn't see from the first video, my laser bed, the Z bed here, does not move. It's a stable bed. It sits in the same position. My laser does shift up and down for the few inches that I need to make an adjustment on to keep it in focus. Most of my cuts are done from paper thin to 1/4 inch, and if I use offsets, one of the things is aluminum beds, the laser will reflect off of them. That's the reason why you have a honeycomb bed, because it's very thin and yet will hold the product. If you, for instance, if I'm doing acrylic, I will get reflection off of that, and it may reflect back up off of the bottom of it from the aluminum. It doesn't typically do it on a regular basis, but it can do it. So if you're dealing with a project that you don't want that type of action to occur, offsets are simply one of the things that you use, and then I can adjust the laser head to put it in focus on the product that I'm working on. And so that's why the bed doesn't move. It doesn't work for the most part. But I do need to clean underneath there because small pieces fall underneath there. While it is 6 inches to the bottom, the laser is still generating power beyond there. There's actually a steel plate underneath there to absorb that energy. But if I have a bunch of scraps and pieces underneath there, I do have to vacuum it up occasionally to pull out the small fragments that come out of there, especially when I'm doing windows and mirrors and windows and doors and things like that. So to set this up and to get it done, I'm going to talk about just a little bit about some of the products that I use. The number one product I use is 1/8 inch MDF. The reason why I like this is it's durable, it's thick, the laser carves it very well. Doing brickwork with this is fantastic. Here is some brickwork that it's done on the laser, and it does an excellent job at carving that brickwork. And it's very durable, makes a nice modeling product. Once it comes off, it's brown like that. I simply then just prime it and then begin painting it just like I would any regular model that I would work on. And it does an excellent job with it. The products I like to use is I use basswood. I know guys who use balsa, but I don't use any balsa. Basswood, 3/4 or not 3/4, 1/16 inch, 1/64, 1/32 birch plywood, which you can find at available. I use that for trim. I use a lot of the basswood. The other product that I use a lot is from a company called Richland Woods, and these guys are located back east. This is a MDF product that is impregnated with some type of resin. It cuts fantastically well, and unfortunately it's tough to get this stuff. I have a source that I can't share, but it is a challenge to get this because it is sold. Richland Wood sells this in giant rolls of about 10,000 feet, and we're talking semi-truck delivery. So as a modeler, if I ordered it, I'd have like 100 lifetime supply of this stuff. And this would be great if somebody wants to start a business. Buying this stuff and breaking it down and selling it, you probably could make a killing on this because this stuff is really very good. These are where the windows were, and you can see the little slots. Those are each about 1 millimeter wide. And if I was to want to make an ironworks tower or something like that, this would be fantastic to cut with. It's very durable, extremely fantastic to work with on the laser. And I'll give you an example. Here's some windows I cut. So this is the window that we're going to be cutting here in just a little while. You can see that's going into the building that I've been working on, the Colorado Saddle Works. Here's a basement window that I cut for one of the houses. I'm trying to get it in focus, and if I put it maybe right there, it'll be a little easier. Really small. And I've done, I did some lattice work on a house to line the outside of the porch. And the holes on them were about 0.5 millimeter opening. So it's really takes the laser extremely well. Fantastic product. If you got a laser and you want to do that kind of stuff, try to find it. Again, it's called polybak. This is 17 thousandths. It comes in different sizes. But you can find, if you can get a source for it, it's really very much worth it. Fantastic. So in any case, what we would do then is the laser would be set up. As you can see on mine here, I've got some tape here. Because this bed moves and I have to clean underneath there, I lay this tape down, and I have a program on the laser that basically runs a line so I know where to line up my product so I can get it square into the laser. Now, I don't have to line it up every time square in the laser. I could actually just set it up and say, hey, I want to cut right there, and well, we're going to show you what that takes. So typically when I finish my drawings, I put them on a thumb drive. This, I'm going to close this program here. We'll reopen it. And I bring it to my computer. Now the computer out here, it serves one purpose and one purpose only. It basically is just to feed data to the actual computer, the controller here that actually runs the laser itself. I could take that thumb drive and stick it right into the controller, and I'm going to rotate this over just a bit. I could stick it right into the controller, and it would read the DFX file with no problem. But I like putting it on the computer because I can store it on the computer. This will hold, I think, well over 80. It depends on how big the cuts are, but you know, right now I've got like 60 files on there. So it does hold them, but the problem is, say for instance, when we're cutting the windows, I have all 40 windows programmed into the controller. But let's say I have to come back and I only want to cut 2 windows because I'm short 2 windows, or I can't find them, or they're broken, or whatever. If they're on this computer here and I saved it, then I can go back, pull that file down. I can say I only copied 2 of those windows, put them on a new file, then say I just need to cut these 2 windows, where I can't do that on the controller. So that's why the computer is out here. So basically, the software that I use is a Chinese software. It's called LaserCAD. And if you look into it and you get into like the help things, it's the biggest joke running around. If I were to say, okay, and get help, it has nothing here. And at times it speaks Chinese to me. So take it for what it's worth. You know, it works. It works extremely well. But basically, I would take the file, I would open it up, and I would import the file. I simply pull it down from the name of what I need, which is Windows, and you can see it there, I believe, yeah. And then I would open it, and it's going to put it right here in the center of my work area. Now, this square represents the work area on this laser. So the program is set up to match bed cutting area to what I can do in here. I'm just going to put it in the upper corner because it really doesn't matter where you stick it in the corner. In probably the more sophisticated softwares, you could probably tell it where to put it, and it would numerically know exactly where you put it. You know, cheap Chinese software, take it for what it's worth. The next thing I would do with this is I would basically take and I have to tell the instrument, the laser and everything, how much power and how fast it needs to go. I have a book, it's my laser workbook data, and in here is, you know, things like on the laser tube, what's my power source. I've worked up power grids on this, so I know exactly the performance of my laser based on voltage and watts going in. This one's based on so I would set a percentage of power, and this is telling me how many milliwatts of power I'm going to be throwing through the tube. The tube, my tube is a 60-watt tube, can only take no more than 12 milliwatts. Anything over that, I'm overdriving the tube. And tubes are an expendable item. They are a light bulb, basically. And if you know anything about light bulbs, you can take a 110 volt light bulb, and if you push it up to 112 volts, it probably won't burn out right away, but its life expectancy is drastically shortened by that. The same holds true with laser tubes. You can drive so many milliamps to them, but once you drive more milliamps than it can handle, you're overdriving it, and you're just shortening the life of the tube. So, and a tube is, you know, $300, $400 based on what quality of a tube you get. The tube I have in there right now is over a year old. I probably will get at least, I'm assuming, 6 to 12 more months out of it. Life expectancy of a tube is, I'll be fair with you, I bought a cheap Chinese one, the 40-watt one that I bought. It lasted me 5 months, tops. There are gases in there, and some of those gases don't want to stay in there. Either helium, hydrogen, one of them is very hard to contain. And so the cheap Chinese ones, your shelf life is and it is shelf life. It's not operational life. It's shelf life that they measure on these things. My tube that's in here right now is a much more high quality tube. You can find them, and they're, believe it or not, the Chinese make some of the best tubes out there. They really do. Japanese make some really good ones too, and the U.S., oh, we don't really have any manufacturers yet that I know of, although Boss makes some, and I'm tempted to try some of their tubes in my laser, and that's probably who I'm going to use next. They have some really good tubes. But in any case, beyond tubes. So the file is now here, and I will actually go into here. One of the things that are in here is I keep a record of what I've cut and what the settings are, what the settings are for my tube and how well it cuts. So that when I bring a product in here where I'm cutting polyback, I already know a basic baseline of what I'm going to need. So in this case here, the baseline that I need is 33% power with the corners being cut at 28. So a CNC machine or a laser, when it comes to a corner, it slows down because it knows it has to make that cut. Well, I need to reduce the power off of that a bit so I don't overburn the corner. So I'm saying, hey, reduce it down to 28% when you go to deaccelerate and make that corner cut. And you saw from the windows I got, it didn't look any different. That's just a matter of trial and error and figuring it out. And I'm going to cut it at about 20 millimeters per second. Once I've set that up into there, I simply just download it to the controller. I name the file and I download it, and voila, it's on my controller. So what's up here is now down here. Now, the only thing left to do is to basically get my product someplace. Now I've set the origin on the laser to be this spot right here, and I can simply say, hey, I've got my product in here. I want to make sure that I'm going to cut and I'm not going to run off my product. So I can tell it, hey, would you box this? And then I inspect it to make sure that at no point does this head leave the product. Once I've done that, it's just simply a matter of turning on the fan, turning on the laser, and saying, okay, go ahead and run it and cut it. And that's what we're going to see next. So hold fast and we'll go from there. Okay, so I'm all set up. This is going to cut 40 windows. It's going to take these 40 windows approximately 6 minutes to cut. Obviously, I'm not going to waste 6 minutes of your time watching this laser cut, but I will start the cut and then bring it in towards the end so you can see what's going on. So the fan's on, the laser's on. I'm going to leave this open so you can see this better. And here we go. So there you go. That is 40 windows cut out, and we'll just pop these out, and you can see. You just pick them up and take them out, and actually sometimes the best way to do this is just with a little big of a, once you get one, it makes it easier. And there you go. Just as simple as can be. And we're all set. So until next time, happy modeling.